All right, thanks for coming back, folks. Tonight we're going to deal with a couple of topics, after which we'll just move on to something else. I'm just going to conclude the arithmetic series today, but in the future, I may solve some problems and then post on that I'll post the problem on if I do solve problems in the future, I will post it under that category of arithmetic, okay? Now, today we're just gonna cover a couple of topics: real number line, expressions, equations, inequalities, exponents, roots, like square roots, absolute value, order of operations. These are topics that we need to talk about because the kids need to be introduced to this stuff, because you don't know. Later on, the kids may want to go into mathematics, right? So they need to know this as early as possible. I'm not going to go into details. I will just introduce them in a simple format here, okay? Before I continue, please subscribe to my channel, like and share this video, leave comments or questions under the video. If you're helping your kids to do their homework and there's a problem you have, just ask the question. Ask the question, I will try to answer it as much as I can, okay? So the first thing we're going to deal with today is the real number line, what I call real number line. First of all, see the images there? You see the first image you're looking at there, everybody knows what is GPS. This is GPS right here. This thing here is GPS. The first image on the top left is the GPS. We have GPS on our phone. You can buy GPS device and they use it, you use that to find anywhere you go in the United States, right? The GPS is based on real number line. I will explain that further. The real number line is also called, another name they have for it is XY plane, or they call it the Cartesian Coordinate system, right? The GPS we love to use is based on that, because what normally happens is the GPS calculates the Cartesian coordinate of a point they're looking for, a person or a point or address you're looking for. The GPS will first calculate the Cartesian coordinate, the XY plane coordinate, right? The XY location of that object. After that, then it will compute the latitude, the longitude, and height, whatever. And then it will locate that object. Sometimes they use satellite. That's why you see satellite here. Well, not sometimes, they use satellite. That's a satellite. They use a satellite to also do the computation and help to locate the position they're looking for. Now, look at this image here, the right bottom one. This is where they call the Cartesian coordinate. You have the y-axis. This is the y-axis, the one that runs up and down is the y-axis. And the one that runs from left to right is called the x-axis. I will get into that in a minute. And then you see the American soldiers in this last. American soldiers can see deep in the mountains of Colorado and kill anybody anywhere in the world. That's because of they have the ability to locate anybody anywhere, using the GPS that is installed in drones and the airplanes, okay? So here are the topics we will cover. We will cover this stuff. We'll cover it in this order. We'll go from here, we'll go down that way, and then from there we'll go here, we'll go down that way, okay? So let's get going. All right, recall that when we were dealing with addition, subtraction, multiplication, and division, I said that we were dealing with what? Whole numbers, right? Whole numbers. Whole numbers. That means whole numbers consist of 0, 1, 2, 3, 4, and keep going to infinity, right? But there are numbers there. These are called positive numbers. These are positive numbers. There are also numbers to the left of 0. There are numbers here called -1, -2, -3, -4, right? also going to infinity. When you put all the negatives and the positive and zero together, you get what is called real numbers. It's called real numbers. The whole thing is called real numbers, right? That includes zero. It also includes, like, over here you have half, over here you have minus half, something like that, so it includes everything, right? The best way to represent it is the Cartesian coordinate system. The Cartesian coordinate system is also known as XY plane. Sometimes they call it the coordinate plane or the coordinate system. It doesn't matter. The coordinate plane, So the word Cartesian. It was coined from the name of the guy that designed it. His name is René Descartes. Descartes. He was a French philosopher and mathematician that lived around 15 something, died around 16 something. You notice the word Cartesian came from his name right here. It's an abbreviation of his name. Okay? Now, the Cartesian coordinate system is represented by a vertical line, a horizontal line, right? Usually go like this, a vertical line and then a horizontal line like that. Okay, this one is called x-axis, this is called y-axis, right? It's called xy, and that's why it's called xy plane. First of all, this is called zero here, right? This, you can label it as 1, 2, 3, 4, 5, and keep going, right? Remember up here I showed you how this go here and then the negative go here, right? And then the left side of zero, you will have -1, -2, -3, -4, going to infinity, right? This go to infinity. The same thing with y-axis. Y-axis, you have, let's say you have 1 here, 2 here, 3 here, 4 here, going up to infinity. And then you have negative numbers, below 0 too. -1, -2, -3, -4, going to infinity, right? These numbers here that are positive, they call positive numbers, right? Positive numbers. You know about that. Positive. We've been working with them. Positive numbers. So usually we can write it like +2, +3, but we don't put that. We'll write it as 2 or 3. The assumption is that positive sign is there. And then on the other side, you have negative numbers like -2, -3, they're all there. But you have to put the negative sign. You cannot remove the negative symbol. Negative numbers, right? Right? Like I said, you have to put the negative sign. If you don't put it, then somebody would assume that you write in a positive number. All right? So that has to be put in there. Now, notice this. Notice this in the XY plane. Now, notice that in the XY plane, every dot in the system represents an ordered pair. It's called it's usually called X, Y ordered pair, like that. It's written like that. This one will represent number from the x-axis, and this one will represent number from the y-axis, right? So this point here, you go down, find the number it corresponds to in x-axis, and then you go this way, find the number it corresponds to in the y-axis, and then you write it like this. You write it like 4, 3. Like I said, you put the x first. The x coordinate is 4. The y coordinate is 3. All right. So every point is represented like that, and the x is written first, y is written second, right? The 4, 3 example, right? They call it ordered pair, right? Ordered pair. 4 is x coordinate, 3 is y coordinate. All right. And then there's something called origin. I already mentioned that before. Origin, the 0 here is called the origin. It's called the origin, right? That's what they call it, the origin. All right. So let's describe some properties of the xy plane. All right. Let's describe some properties of the real number lines. I mean, these are observations I noticed. Okay, notice that if you're on the real number line and you pick up a number like 6, notice that 6 is said to be greater than 3. Means that 6 is on the right of 3, right? And then notice that if 2 is on the left of 6, that means 2 is less than 6, right? So this is how they represent it. Let me draw a line here. This is you can draw just a segment of the Cartesian coordinate, right? This is 0. Let's say 2 is here. Let's say 6 is here, right? Okay. And let's say 3 is somewhere here. Okay. They say if 6 is in the right of 3, and then what they say 6 is greater than 3. It's written like that with that symbol there. And then notice that 2 is on the left of 6. Also, they say that 2 is less than 6. They write it like that. Notice that 2 is equal to itself, right? So sometimes they write that, I don't want to confuse you. They write that 2 is less than or equal to 2. Don't let that confuse you. That means 2 is equals to 2. So, and then, so this property means that let's say you have, if you have 2 real numbers, right? If you have 2 real numbers, let's say A and B are real numbers, right? These are 2 real numbers. Then there are things, one of the following has to be true, right? Either A is less than B, right? Or A is greater than B, or A, right? Or A is equals to B. One of them has to be true. Three of them cannot be true, right? One of them has to be true, so you need to keep that in mind. So let me get you more properties. Yeah, I just want to finish this, then get you more properties. Let's say this property says, listen, each if you take any real number, right, except 0, that 0 is on the number line. Let me draw it again. You put 0 here. This is 1, 2, 3, and so on, right? And then you have -1, -2, -3. Okay. 0 is a real number, but we're not talking about 0. Any number except 0. If you take any number, each number except 0 has an opposite. So let's put 0 here. If you take 3 right here, right? If you take 3 right here, 3 has an opposite, yeah? Number 3 has an opposite, which is -3. That's all that is saying. Every number has an opposite. You can choose another number. Choose a 4. You'll find the opposite over here, minus 4. That's all that is saying. Alright? And then note that each opposite are located the same distance from 0, but they have opposite signs. Right? So, if you take 3 and you go to 0, it will be 3 units, right? That's what that's saying, 3 units. Okay? And then if you go from 0 to negative 3, it's still 3 units. The only difference is the 3 here has a negative sign to it, and the 3 here has a positive sign. Like, we usually, well, what they say, 3 can be written, 3 over here can be written as plus 3. 3 over here can be written as minus 3, right? But we don't normally write it like this. We just write 3 with the assumption that the positive sign is there. So every real number on the real number line has an opposite except 0. 0 has no opposite. So that's what that property is saying there. I just made these observations on my own by reading a couple of books. So now consider this. Consider minus 4 and 4, right? Let's consider that. Draw the line. This is x-axis. Put the 0 here. And 4 is up somewhere over here. Minus 4 is somewhere over here. So look at those. Consider those two. What do you notice? Well, we know, according to what I said above, minus 4 is the opposite of 4, right? That's what we said above. Notice that minus 4 is not equals to 4, right? Right, but 4 is equals to 4, minus 4 is equals to minus 4. Now, notice this trick. Suppose I write something like the minus 4, and then I put another minus in front of it. What does this mean relative to what we drew up there? Relative to this line here. What does that mean? Well, this is the opposite of, right? Opposite of minus 4. Right? It has to be the opposite of minus 4. Actually, from this property here, it has to be opposite of minus 4, right? So in other words, this is the best way to show, on the Cartesian coordinate that minus 4, right? Minus 4, then he put a negative sign in front of it. It's the same thing as 4. You see? Because this here is opposite of minus 4, right? Now, but check this out though. This is called, this idea here is called the double negation property of real numbers, right? Now, the best way to see it is, when we do a couple of addition and subtraction using the real numbers, right? Let's do this. Let's do addition, subtraction, multiplication, division, using what they call sign numbers. When they say sign numbers, what they mean is like negative 4, positive 4. We normally don't write the positive number here. So, but let's do operation using that, right? Using the idea of negative 4 and the positive 4, right? Now, notice that, before I do that, notice that 0 doesn't have any opposite, right? So, if you add 0 plus any number, like say this number, let's say A is a real number. You add 0 to A, what do you get? You get A. So, 0 just leaves if you add it to something, it leaves that number unchanged. It doesn't change the number. So if you add 0 plus 1, you get 1. You add 0 plus 20, you get 20. So what they call that, they say 0 is an additive identity. I don't want to confuse you, but that's what they say. 0 is an additive identity, because whatever you do add it to 0, you get that the same thing. Okay, and then 1 has the same property. Let's say you say 1 times a, what do you get? You get 1. It doesn't change that thing. It leaves the number unchanged. For example, 1 times 2 is 2. It doesn't change 2, right? 1 times 4 is 4. It doesn't change 4. In this case, they say 1 is multiplicative identity. It has to do with multiplication. 0 has to do with addition, right? This is called let me write that. A multiplicative identity. That's what that is called. Okay? So I want to get that up the way. And then notice there's no identity associated with 0. Right? Because you can't divide any number by 0. You can't do that. This is undefined according to mathematicians. You can never divide by 0. This is undefined. So never try to divide by 0. So now note this. Negative a is called negative a. I'm sorry, negative a. If you put a dash there, it's called negative a. If you put plus sign in front of a, it's called positive. I'm just repeating myself, but it's okay. It's called positive a. Alright? It's called positive a. Normally, why I'm saying that is, you don't say negative a. You don't say plus a. I know sometimes I make that mistake, but the proper pronunciation is negative a. It's in negative direction. See, after 0, negatives are here. Negatives. Negatives are here. And then these are positives, right? The same thing with the y-axis. This is y-axis here, y. Down, the numbers down here are negatives, right? The numbers up here are positive. Same thing, so always keep that in mind. So let me give you some example how you can use the Cartesian coordinate to explain something like addition, subtraction, stuff like that. Let's do example. Let's say you have they say add 3 and 4, right? You add 3 plus 4. First, what you do, you draw the segment of the Cartesian coordinate that you need. You draw it like that. You say here is 0, and then you say 1, 2, 3, 4, 5, 6, 7, 8. You can split that up like that, and then what you say is you are given 3. And then you add 4 to it. So what you do, you start from 0. You go from 0, you count 3. 1, 2, 3. You count 3 to the right. And then from there, you count another 4. 1, 2, 3, 4. You see, we'll land on 7. So basically what that means is 3 plus 4 is equals to 7. That's what that means. That's how you use the Cartesian coordinate to demonstrate that. Let's do more examples. Okay, let's say you're given -3 added to -4. How do you demonstrate that using the Cartesian coordinate? You draw the line again. You put, it doesn't matter where. Let me see. You can put 0 here. It doesn't matter. And then since all the stuff are negative, what you do, say -1, -2, -3, -4, -5, -6, -7, right? -8. So we're dealing with negatives, right? And then you start from 0. See, you start with this number, you count to 0. So you go, Negative means you go leftward. So you start from 0, you count 3 to the left. 1, 2, 3. So you stop at -3. Then you continue. You count. You go left towards another 4 units. You go 1, 2. 1, 2, 3, 4. See, it will land on -7. You see that? So we'll land on -7. Okay, so that means -3 plus -4 is equals to -7. See? That's how you demonstrate that. Okay, let's do another example. This time it's mixed. +3, right? +3 plus -2. How do you demonstrate that? Again, you draw the Cartesian segment of the Cartesian coordinate. So you can put 0 here, and then 1, 2, 3. 1, 2, 3. All right, you can put 4 if you want to put one more. And then the negative direction, you put -1, -2, -3, -4. Okay, I think we'll have enough. Now, you start from 0. Now you're giving 3 first, +3 first, right? You start from 0. You go to the right direction. Count 3 off, 3 units. 1, 2, 3, right? And then you start from there. You count 2 units back because we're dealing with negative numbers. So you start from there. You say 1, 2, 2 units. What will land on 1. See? So then you said 3 plus -2 is the same thing as 1. See? That's how you use that, man. That will help you in a minute. Let me show you something in a minute. All right, let's do this example. One more example, and then we'll move on to something else. Let's say I say 4 minus 8. How do you demonstrate that using a Cartesian? You go like that, you draw, put 0 anywhere you want. You put 0 there, then you go 1, 2, 3, 4, 5, 6, 7, 8, right? You divide it up like that. Okay, and then you go the other direction too. You say -1, -2, -3, -4, -5, -6, -7, -8. I just want to make sure we have enough number putting in. Okay, then you go from 0 because you have 2. You go from 0 to, I'm sorry, not to 4. You go from 0 to 4. 1, 2, 3, 4. You go from 0 to 4 in the right direction, rightward direction, and then from there you go to -8. So from 4 you go 1. From 4 you count 8 units to the left because you're dealing with -8. So we have 1, 2, 3, 4, 5, 6, 7, 8. You see where we landed? We landed on -4. So that means that 4 minus 8 is equals to -4. That's usually what happens. That's how you use the Cartesian coordinate system to locate the operation of addition and subtraction. So based on what we know, what we practice above, I can give you the rules like this. If you have a positive number, this is when it comes to multiplication. You're multiplying what they call signed numbers. When you're multiplying signed numbers, right? So these are the rules here. If you're multiplying signed number, if you have a positive number and a positive number, you multiply them together, you will always get a positive number. Okay. When you have a a negative number, right? You multiply it with a positive number, you will always get a negative number. When you have a positive number, you also have a negative number on the right hand side. It doesn't matter. You will always get a negative number. I'm sorry, these two are the same. So whenever you have a negative number multiplied by something, you get a negative number, okay? Let me give you an example. I will give you an example of each. I'll give you an example of each. Let's say you say 2 times 3. You always get 6, because both number 2 and 3 are positive numbers, right? Now, supposing here you have an negative 3 times 3, you're gonna get negative 9. Suppose you have 3 times negative 2, you're gonna get negative 6. So that's what that is saying there. I don't have enough time to go into this in detail, so I just give it to you. But that's how you understand when you're doing what do you call that, multiplication of sign numbers. Suppose you're doing division of sign numbers. You're doing division of sign numbers, right? Sign numbers. There are rules there too. So what happens is, you say, if you have a positive number on top and you divide it with a positive number below, what will you get? You get positive number, okay? Now, suppose you have negative number on top and you divide it with a positive number on the bottom. What do you get? You're gonna get a negative number. You always get a negative number in that case. The same thing, even if you switch the negative and positive over. You switch them over. So if you have a positive number divided by a negative number, right? By a negative number, what do you get? You will get a negative number. Okay, that's what you will get. So I'll give you an example in each case. Right here, let's say you have a 12 divided by 4. Both 12 and 4 are positive numbers. So what you will get? You get 3. It's a positive 3, but we usually don't write it. Let's say you have negative 4 divided by 2. What do you get? You get negative 2. Let's say you have 6 divided by negative 2, right? What do you get? Negative 2. What do you get? You get negative 3. So that's how that breaks down. Negative numbers and positive numbers, when you multiply and divide them with them, that's what you get. Okay, so let's move on. Now we're going to deal with expressions. What is an expression? First of all, before I say something about expression, I will talk about variable. We use variables in the past. A variable, right? A variable is it's a letter that varies. You use it. It's not a constant. A variable is just a letter. A letter used to represent a number. To represent a number. Yeah, it's a letter used to represent a number. That's the meaning of variable. So you can say, well, let X represent 2. People talk like that. You see that in the in algebra or in arithmetic. You can say let Y represent, that's how they write, let Y represent 4. Let Y be equals to 4, let X be equals to 2. So these are variables. X and Y are variables, right? Now that you know what is a variable, what is an expression, what you learn here, it also applies to coding. Like if you If you like C++ or Python, they talk about expressions, variables, and constants there too. So an expression is a statement. An expression is a statement, okay? A statement used, I'm sorry, and a statement that uses numbers, right? Uses numbers and variables. That's why I have to define variable first. And variables with math math operations, right? Okay. Examples are, when I say math operations include like multiplication, addition, subtraction, stuff like that. Subtraction, division. So basically what that statement is saying is this is an expression now. An expression. That's what an expression means. Okay, what that is saying is this can be, and this is an expression. X plus 2 is an expression, right? Y times 4 is an expression. Or you can say X divided by 6, or 6 divided by X. All these are expressions, right? So you can use that to evaluate stuff. Let me give you an example. I can say evaluate 3x plus 6 when x is equals to 2. What do you do? Then you take 2, start substituting, you substitute 2 into here. So you say 3 times 2, since x is 2 plus 6, 6 plus 6, 12, right? So they can give you a problem like that. Say evaluate, another example, evaluate the expression. That's why I want you to know what is the expression. Evaluate the expression 7x plus 2 when x is equals to minus 1. They can give you a problem like this. What do? You write the expression like I did before, then you substitute x equals to minus 2, 7 times minus, not minus 2, minus 1, plus 2. What do you get? You get minus 7 plus 2, you get minus 5. Basically, that's what they're saying there. So you can see stuff like that. You just evaluate it and go. It's nothing mysterious about that. Okay, suppose I give you another example. Say evaluate this expression. Evaluate the expression. Evaluate the expression 10x over 2 when x equals to minus 4. Then you do the same thing we did before. You said 10x times minus 4 over 2. What do you get? You get minus 40 over 2. You get, I keep saying minus, but you get negative 20, right? That's the solution right there. So basically that's what that's saying. You manipulate. They can give you two variables in an expression. They can say, another example, they can say evaluate this. Evaluate this expression, the expression x plus 3y, right? When x equals to 1 and y equals to 3. So you just put the variable into the equation. Into the expression. You get 1 plus 3 3 times 3, right? And then you get 1 plus 9, you get 10. That's what they're saying there. Now we define the equation. I use the word equation by mistake, but see, it has a meaning. What does an equation mean? Equations. What does an equation mean? An equation, right? An equation is a statement. A statement that says two expressions. You see that I'm using the term I showed you before. Two expressions are equal. That's why I tried to define expressions before. Anyway, so what does that mean? Well, note that expression contains variables, right? So equation will also contain variables, right? I want to get that out of the way. Let me give you an example. Let's say solve for this. Solve for x. Solve for x in the following equation. 3x minus 3 is equals to 2x plus 3. Alright, solve for x. What do? So what you do, you start by moving the similar things in one direction, right? You see the number with the variable 3x, right? And move this to the left. It becomes minus 2x. Is equals to 3 plus, you move this over, plus 3. So if you do that, it becomes x is equals to 6, right? I hope I'm doing it too fast. But what you guys normally do, you subtract this, subtract that, add that, But anyway, so let me give you another example. Sorry if I'm going too fast. It says solve this. Example, solve the equation. X plus 2 is equals to 14. So what do? You start by moving similar things to the same side. You leave x here and you move 2 over. 14 minus 2, it becomes minus. Because what some people do is say subtract 2 here, subtract 2 there. I will get to that when we get to algebra. But anyway, so then you simplify that. It becomes x equals to 14 minus 2 is 16, right? I'm sorry, it's 12, not 16. So that's your solution right there. Let me see what else I have for you. Suppose you do see this example. They say solve the equation. Solve the equation 30 minus x over 6. Alright. See, you don't see it as equation because of the way it's written. You can write it like this. 30 is equals to, move it over, x over 6. See, that's why it's an equation. But another way to do it is you can write it like this. 30, no, another way is 30 over 1 is equals to x over 6. You cross multiply. Remember we talked about that before. You cross multiply, you have x is equals to 30 times 6. What do you get? You get 180. X equals to 180. That's the solution right there. Okay. One more example will go. Minus 3 over 7x is equals to 3. Now, to solve this, you have to, write it the way you can see the problem clearly. You write minus 3x over 7 is equals to 3 over 1. You cross multiply, man. If you cross multiply, you have 7 times 3 is equals to 3 x minus 3x times 1, right? It becomes minus 3x is equals to 21, right? It becomes x equals to minus 21 over 3. What do you get? You get minus 7. So that's the solution right there. So let's do something else, man. Now we're gonna deal with inequalities. Recall that initially I told you that 6 is greater than 3 can be represented as, or it means, it doesn't matter, means or it can be represented as, this is 0, 3 over here, 6 is over here, right? So 6 is on the right of 3 in the number system. And then I said 7 minus 9 means or can be represented as 0 here. You put, if 7 is here, 9 is here, it means that 7 is on the left of 9. It's less than 9. Now, this gives us the idea of inequality, right? It gives us the idea of inequality. An inequality, let me define it for you. An inequality is a statement. It's a statement. A statement that compares two expressions, right? It compares two expressions, or you can also compare two numbers. Sometimes it compares two numbers, or it compares two numbers, like I showed you above, two numbers, right? See? When you say 6 is greater than 3, you're comparing 6 and 3. And that's an inequality there. Okay? So the sign for an inequality, the sign, right? You got signs. I'm sorry. The signs for inequality can be like that. A is less than B. Or they can say A is less than or equals to B. Or they can say A is greater than B. Or they can say A is greater or equal to B. These are all signs of inequality. That one there, that one there, that one there, that one there. That's what they use to represent inequality, okay? Let me give you some examples. See, 4 is less than 10. They're comparing 4 and 10. Or they can say 4x plus 1 is less than 10y plus 3. You see? So the first one here, they're comparing two numbers here. They're comparing two expressions. That's all that is saying. So let me give you the way they may write it example. They may say simplify the following: x greater than 7, right, plus 2, right? So all you do, just simplify, say x greater than 9, that's all. Or they can say simplify x minus 4 is less than 1. Basically, you're solving the problem the way you solve equalities, right? You move things around. You can then say x less than 1 plus 4. That means x less than 5. But basically, that you simplify it right there. They can give you division too. let me give you an example. There's a rule that goes with that. They can give you simplify x over 2 is less than 3. Okay, so all you're gonna do, you're gonna say a form of cross multiply. You say x is less than 3 times 2. That means x, same thing as x less than, sorry, my less than is looking ugly, man. It's less than 6, right? But there is a rule though. If you move things around and multiply by negative number, you switch the sign of inequality. But I think it's too much for this course. We'll get into that later in another course. So let's move on. All right, let's deal with exponents. Notice that 2 times 2 times 2 times 2 can be written as, well, this is the same thing as 2 multiplied 4 times, right? So this can be written as 2 raised to the power 4 because it's 2 multiplied 4 times. See, the 2 here is called the 2 is called the base, and the number put up there on top is called the exponent. The exponent, another name for it is power. It's 2 raised to the power 4. That's another way to say it. 2 raised to power 4. That's another way to say that thing up there. Okay. Anyway, note that exponent is no more than a repeated multiplication, right? Because you see, if you have 3 raised to power 3, is the same thing as 12 times 12 times 12. So exponents is no more than repeated multiplication. The same thing if you have 120 raised to power 3, is the same thing as 120 times 120 times 120, right? 120 multiply 3 times, right? That's all that is saying, man. There are things you can do with exponents, but there are rules that guides the manipulation of exponents, right? But I think it will be too much for this course. There are rules like if you have exponent to raise to power, if you have a number raise the exponent right there multiplied by another number, raise the exponent there, equals. But you see, I don't want to get into that. It's too much for this course, so we'll leave that alone. Let's go to roots. In the English language, the word root, you remember when we say root, it means a source of something, right? Root means a source of something. Your root means a source of your source going back many generations, right? That's what root, we usually understand root. But in math, root means the source of another number going back to repeated multiplication. The source of another number that can be traced to repeated multiplication. So I don't really know how complicated I want to make this. For example, 3 raised to power 2 is the same thing as 3 times 3, we know it's 9, right? 3 times 3 is 9, because we got the 9 through repeated multiplication of 3, right? So they say 3 is the source of 9, right? Or they say 3 is the root of 9. They say 3 is the root of 9, right? That's what they say. So because why if you multiply through a couple of times, you get 9. We can also have a cube, what they call a cube. That in there is called squared. If you raise something to the second power, right, it's called squared. That means it means 3 squared. 3 squared, right? But we can have also a cube. You could have 5 raised to power 3, which is 5 times 5 times 5, which will give you 125, right? So that's they say 5 is the cube root of 125. That's how they say that 5 is the cube root of 125. Generally we can say a raised to power n. It's the same thing as a times a times a. You keep going n times, right? N times. Again, I don't want to make this thing too complicated. So we say a is the n root of a times a times a times n times, right? Okay. There is the sign. What sign do you use to represent root? There's this sign. This sign is represent. It's a square root, right? You can have this. Sorry, this is cube root, right? And then you can write this n root. This is n root, right? The sign here is called the radical. It's called radical sign. Radical sign. You read that if you start reading stuff. And note that, let me give you a couple of examples. Note that if you write 2 to put 9 inside the square root symbol, you get 3. And then if you write 3 in cube root, you put 125 inside there, you get back 5. If you do fourth root, you put 81 in there, you get 3. Okay. Well, like I said, I don't want to make this too complicated. See that there? You can write that as 9 raised to power 1/2, right? And this one here, you can write it as, if you put x in there, you can write it as x raised to power 1/n. To understand that, look at this. This is let me see. It will be 3 raised to power 2 multiplied by 1/2. You divide this out, you get 3. You see that? So, but you know that square root of 9 is 3. See? Square root of 9 is 3. But I don't want to make it complicated. So we'll leave it there. Let me go to something else. Yeah, we'll just leave it there like that. But let me see what else I want to call that. We'll go to absolute value. There's something they call absolute value, right? Okay, absolute values or absolute value. Remember the Cartesian coordinate, you have 0 here, you have 1, 2, 3, 4, and then you have -1, -2, -3, -4. Put all that there like that. See? So basically, absolute value, what that means, absolute value is absolute value of a number is the distance of that number from 0. And that distance is always positive because you're not going to have a negative distance. If you drove from your house to work, it's only 4, let's say it's only 4 miles, you're not going to have negative miles, right? So absolute value is a distance. So absolute value is written like the sign. The sign for absolute value is this. It's a two, what do you call that? Two line drawn vertically like that. So you say absolute value. Example, absolute value of 4, is 4, because it's distant from, from 0 to 4. The same thing as absolute value of minus 4 is always 4, because it's always positive, right? So it's just distance from here to here, distance from here to here, and the distance is always positive. The question that is really intriguing is, since absolute value of 4 is 4, right? And then absolute value of minus 4 is 4. Suppose you have 4. Then the question is, so how did you get that 4? Did you get 4 from absolute value of 4 or from absolute value of minus 4? Like I said, I don't want to make this course too difficult. We'll leave it like that. We'll just leave it there. We'll leave it like that. It's okay. Let's do order of operations, right? Order of operations. What I mean by that, operations are like, it's mathematical operations like addition, subtraction, multiplication, division, raising something to power n, or raising something to power 2, or when you have something in brackets. That's bracket. You see the brackets, the two brackets there. We'll call it parentheses. Sometimes called parentheses too. But anyway, so the order of operation. There are several rules, but I'll give you rules as I go. The first rule, rule number 1. When adding or subtracting something, right? If you're adding or subtracting, always start from left to right. If you multiplying or dividing, always start from left to right. Okay? Let me write it down. When adding or subtracting, when multiplying or dividing, right? Sorry. When multiplying or dividing, always go from left to right. Yeah, you never go from you never go from right to left. You always go from left to right. I'm gonna give you an example in a minute. So let's give you an example. Here's an example. Suppose you're given to do this: 11 plus 9 minus 4 plus 2 minus 7 plus 26. All right. Notice that what is there is what is involved there only addition and subtraction, right? So when you do an addition or subtraction, you just go from left to right. You're gonna be okay. Don't jump all over the place. Never go from right to left. You go from left to right. Okay, so then you start from left. You say 11 plus 9 is equal to what? 11 plus 9 is 20, right? And then after you get that, you rewrite the problem. You put 20 here. You say 20 minus 4 plus 2 minus 7 plus 26. So you continue that way. Continue going down. Okay, going from left to right. 20 minus 4 is what? Is you get, let me write that. 20 minus 4. What you get 16. And you write the problem, you write this one here. You say 16 plus 2 minus 7 plus 26. You keep going like that, breaking the problem down until you finish it. Now 16 plus 2. 16 plus 2 is what? It's 18. So you replace that too with 18. 18 minus 7 plus 26. So you keep going. 18 minus 7, right, is what? Is 11. You replace that. You say 11 plus 26. What do you get? You get 38. That's your solution right there. So that's how you do it. You have to go from left to right. If you don't go from left to right, you get the wrong answer. Okay. So let's go ahead and let's do multiplication this time. Let's give you. We'll go to another page. Let's say do this 4 times 2 times 3 times 6. The thing is, order doesn't matter here. Actually, order you do this doesn't matter. Actually, in multiplication, order doesn't matter. Sorry about that. But if you have multiplication added and to addition, right? If you do multiplication and addition at the same time, then you have to follow the order. So you can multiply this in any order. You can say 4 times 2 is equals to what? 8, right? And then you rewrite the problem. Say 8 times 3 times 6. 8 times 3 is 24, right? You rewrite the problem. 24 times 6. And then you finish off, it will be 144. So it doesn't matter. You can also do the problem like this. You can say 2 times 3 is equals to 6, right? You can do 2. So you can do 2 times 3 right here. And then you write the problem 4 times 6 times 6. And then you can do this first. You can say 6 times 6 is what? It's 6 times 6 is 36. And then you write the problem as 4 times 36. And then you get 144. So when the multiplication, you do multiplication alone, order doesn't matter. You just do whatever. You start from anywhere. But check this out though. Suppose you have multiplication and division joined together, right? Suppose you're given this example here. They give you 8 times 2 divided by 4 times 5 divided by 10. Now, here order matters, right? You can't choose whatever you want to do first. You have to go from left to right. You have to head this way, left to right, because this is only multiplication and division, right? You go from left to right. So that means you do 8 times 2 first. You do 8 times 2. What do you get? You get 16, right? 8 times 2, you get 16. Then you write the problem. You say 16 divided by 4 times 5 divided by 10. Now you keep going left to right. 16 divided by 4, what do you get? Let me see, 16 divided by 4, you get 4, right? You get 4. You rewrite it, whatever is left here. You rewrite it, you say 4 times 5 divided by 10. And you keep doing the same thing from left to right. Keep going from left to right. 4 times 5. And then you bring the division down right there. I'm sorry, 20 divided by 10 will give you 2. Okay, so that's how you do multiplication and division, mixed in together. You have to go from left to right. If you don't do that, then you have the wrong solution. Now, supposing you're given this problem. Supposing we have a problem in which addition, subtraction, multiplication, and division are involved, right? You have this problem here. 20 divided by 4 minus 5 times 2 plus 8 times 9. Now, we can use the rule number 1. We'll know the rule number 1. Rule number 1 says when you do multiplication and division, you go from left to right. When you do addition and subtraction, you go from left to right. So let's see if that rule will work with this problem, right? Alright, so what we do, let me rewrite the problem first. 20 divided by 4 minus 5 times 2 plus 8 times 9, right? That's the problem. Let me see. Yeah, that's the problem. Okay. So let's walk from left to right, see if we'll see what happens. All right. So let's do it. So 20 divided by 4, what do you get? You get 5. And then you rewrite the original problem. It becomes 5 minus 5 times 2 plus 8 times 9. Okay, so we keep walking from left to right. We'll say 5 minus 5 is equals to 0. And then we'll write the problem, we'll write that. We'll say 0 times 2 plus 8 times 9. What do we get right here? We get 0. So we'll write this as 0 plus 8 times 9. What do we get here? We'll say we get 8 times 9. And then 8 times 9 is what? Is 72. That's what we got, but this is wrong. That's wrong. I'll show you why. Wrong answer. This is wrong answer. I will explain to you why. Now check this out. Rule number 2. Let's do rule number 2. Rule number 2. Multiplication and division rank higher. Okay, multiplication and division. Multiplication and division they rank higher. Rank higher than addition and subtraction. All right. So what that is saying is, let me see. What that is saying is this. It's saying that is another way to say you must perform multiplication and division before you do addition and subtraction. That's all that rule says. Okay, basically it says that multiplication and division take precedence over addition and subtraction. That's what that rule says. So let's redo the other problem. Let's redo that problem we did wrong. Remember that's the problem here. 20 divided by 4 minus 5 times 2 plus 8 times 9. Let's redo that using the rule number 2. Don't forget what we found before. You will find the answer as 72 before, right? That's what we found before, but keep that in mind. But let's redo using rule. Make sure we apply rule 2, right? So we'll say 20. We'll have to go from left to right. Left to right. Going from left to right, we'll have to do division or multiplication first before we do addition and subtraction. So we have division there. So we'll say 20 divided by 4 is what? 20 divided by 4 is 5, right? Yeah, 20 divided by 4 is 5. So then you write the problem, you say 5 minus 5 times 2 plus 8 times 9, right? Okay. Now see, the next thing we'll have there is from going from left to right is subtraction. We're not going to do it first. we'll leave subtraction and jump to multiplication, going from left to right. So that means we'll do 5 times 2. See how I'm doing it? 5 times 2. Don't get confused, man. It's not minus 5. 5 times 2 is what? 10. We'll rewrite the problem, right? The problem becomes 5. We're writing this one. 5 minus 10 plus, because we're replacing that, 5 minus 10 plus 8 times 9. Again, we'll continue. We'll continue in that direction. Now, we're not going to do 5 minus 10 first. No. We're going to do 8 times 9. We're going to do this first. Okay? You do 8 times 9. What do you get? 8 times 9 is, 8 times 9 is 72. Okay? So you rewrite this again. You say 5 minus 10 plus 72. Okay? Now you can, you still gotta go from left to right. You can't choose which one you do first. You say 5 minus 10. 5 minus 10 is equals to what? Minus 5. And then you rewrite this one. You say minus 5 plus 72. And then you finish up. That will give you 67. Okay, so you see, 67 is not the same thing as what we got before. Before we got 72. That 72 was a wrong answer. So this is the right answer. That's how you do it, man. Let's do that example there. One more example. Again, you remember the rules, right? We'll go from left to right. Multiplication and division takes precedence over addition and subtraction. As long as you remember that, you're not going to make any mistake. But you start going from left to right. Okay, so going from left to right, we're not going to do 14 minus 2. We're not going to do that first because we have to do multiplication first. So the multiplication we'll have to do, you're going from left to right. We're going to do 2 times 7. Notice how I'm doing it. Don't let this sign confuse you. We're doing 2 times 7 is equals to 14. Okay? Once you get that 14, you rewrite the original problem. So you write 40 minus 14 divided by 2 plus 11 minus 16 times 2. And then you keep going doing the same thing left to right. What do? You're not going to do the subtraction first, going from left to right. You see division. You do division first. Okay? You go ahead and do division first. 14 divided by 2. 14 divided by 2, you get 7, right? And you rewrite this again. 40 minus 7 plus 11 minus 16 times 2. Okay, you start scanning. You're going from left to right. You can't do the minus, you can't do the plus. You gotta go down and do the multiplication first, right? So you say 16 times 2 is equals to what? Let me see, 16 times 2 is 32. Okay? And then you rewrite that. It becomes 40 minus 7 plus 11 minus 32. See how you do it? Then you keep going from left to right. You can't jump from right to left. You gotta continue from left to right. Going from left to right, what you do 40 minus 7. What do you get? You get 33, right? So you rewrite that. You say 33 plus 11 minus 32. You keep going from left to right. 33 plus 11 is what? 44. So you replace that with 44, and then you bring down 32. What is that? That's 44 minus 32 is 12. So 12 is the answer. So go through it, practice. If you don't get 12 there, you gotta go back and start start going from left to right, doing multiplication and division first over addition and subtraction. Okay, so let me give you we'll have another rule here. This is the final rule. This is rule number 3. This is the final rule. Rule number 3. Okay, rule number 3. This rule just has stuff for exponents and brackets. This rule says exponents. You know, exponents is called powers, right? Exponents must be done first. Must be done first. First before multiplication. Multiplication and division, right? So you know what you know before. Also, it says also brackets. Brackets are the same thing as what some people call it parentheses. Brackets must be done. Must be done first before exponent. You see that? Exponents are powers. So you do brackets first before you do exponents. You do exponents first before you do multiplication. So basically we added 2 things. The way it breaks down, you gotta keep going from left to right, right? So if you combine the 3 rules, right? Basically what it says, combine all 3 rules. All 3 rules say this. This is what they said. You gotta do bracket first. This is brackets. Brackets, something as parentheses, brackets. Something as parentheses. After that, you do exponent. Exponents are called powers. They call it orders. So you can write it as O. Exponents or powers, right? Although, or root. You know, remember the root, square root and all that. They are known as orders. So we write it as O. That's the reason why they do that. I'll show you in a minute. And then you do division and multiplication, right? This is division and multiplication. You do that next. And then the last you do is addition and subtraction. You do addition and subtraction. That's what you do last. So there's a reason why this is an acronym. The acronym is called BODMAS. I learned this when I was before middle school. We had a very good Indian teacher. It's called BODMAS. BODMAS. So you do brackets first. You do upside, which is exponents and root of square root. You do them second. You do division. Usually they go together. Division and multiplication you do next. And then addition and subtraction you do last. See? So that's what the rules say. So let me give you, they have different acronyms like pendamus or something. But I don't want to confuse you. Stay with one and learn one. They'll come up with the same thing. The one is comfortable with. Whatever acronym you're comfortable with, you learn it and stay with it. I know BODMAS way from when I was small. So I'll stick with my BODMAS, man. You stick with whatever works for you. Okay, so let's do example. This is example 14 plus 2 times 3. Right? 3 squared, I'm sorry. Again, what you do, they say exponent first. You have to do the exponent first. We don't have any brackets, so the next is the exponent. So you say 3 raised to power 2 is equals to 9. You rewrite the problem. Say 14 plus 2 times 9. That's all. That's all. There's nothing to be confused about. So going from left to right, you do multiplication first, right? So you say 2 times 9 is equals to 18. You rewrite that. 14 plus 18. Then you finish up. 14 plus 18 is 32. That's your answer right there. That's all the rules, man. If you remember the rules, solving problem becomes easier for you. Let's do another example. 31 minus 5 times 2 plus 4 squared divided by 4. Now, see, that's exponent right there. Right? That's what you do. We don't have a bracket. So, bracket is like, let's say if they put bracket here, then you do that first. But we don't have bracket. We'll have exponent. That's how you remember the rule. If there's a bracket, sometimes there's a reason why they put bracket to get your attention to do that first. So, but anyway, we'll do the exponent first. What is the exponent? Exponent is what is that? Is 4 raised to power 2 is 8, right? No, I'm sorry. 4 times 4 is 16. So we'll rewrite 4 times 4 is 4 raised to power 2 is 16. Okay, so we'll write the problem 31 minus 5 times 2 plus 16 divided by 4, right? We'll keep doing it, go left to right. What is the next thing to do? You don't do the subtraction. You do the, going from left to right, you do the multiplication right here. So you say 5 times 2 is 10, right? 5 times 2 is 10. So you write the problem 31 minus 10 plus 16 divided by 4, right? Okay, now what do you do next? You gotta do division. Don't do subtraction and addition. You do division right there. Even though it's at the last, it's scan. Going from left to right, you do whatever you're supposed to do first. 16 divided by 4. 16 divided by 4, you get 4, right? So then you write the problem 31 minus 10 plus 4, right? Plus 4. Then you're still going from left to right, right? From left to right, you have to do subtraction first. 31 minus 10, what do you get? You get 21 plus 4, right? And then you finish up 21 plus 4 is 25. So that's the solution there. I think I'm gonna leave this here. Please subscribe to my channel, like and share this video. If you have any comments, leave it under the video. If you have any questions, if you're helping your kids, you're getting confused, write the questions and down there, I will solve it for you. Eventually, I'm going to find a place where if you have a question, like your kids give you a problem, you take your phone and you scan it and you send it to me. I will help you with that. Okay, so please share the video with your friends. Share it with your father and mother. It will help me. So we'll leave it there. I think I'm going to go to algebra. They have algebra 1, algebra 2, and then they have trigonometry. There is a pre-calculus. Pre-calculus is algebra 1 and 2 combined with trigonometry. But I'm going to do all of it. I will start with algebra 1, okay? All right. Thanks for coming by.